Okay, today we are going over what is called data normalization. We've discussed databases before, sets of tables, what they're used for. Of course, designing a database, if you want to do it well, it takes a lot of practice, a lot of skill, a lot of experience. But some of the best minds in data science have come up with some rules, heuristics, that help you to design good databases. Now, these are called the normal forms of databases. We're going to be studying 3 of them. There are more, but the first 3 are by far the most important. So this process of following these rules of the normal forms is called data normalization. And you don't have to do it, but, the best minds in the industry kind of have decided they're good ideas. Largely because they're going to eliminate data redundancy and inconsistencies. One huge problem with databases, especially big databases, is that data will be entered in one place as one value and another place as a different value. This not only means there's a mistake in the database, it also makes any data processing more difficult. One method of analysis might say someone's age is 14 and the other one says it's 15. Which is right? I don't know. And now if you have these 2 different things, you could try to connect those 2 data sets, and they may not connect at all because one believes that you're talking about a 14-year-old, one is a 15-year-old, and they don't think they're the same thing. You can get duplicate entries, and it just cascades. Inconsistencies are bad, and probably present in just about every data system. But following the rules for data normalization, there's less room for them. So, like I said, we're going to discuss today the first 3 normal forms. So, the first thing to learn about these 3 normal forms is that they're sort of nested, like Russian dolls. Everything that is in the 3rd normal form is in the 2nd normal form, and everything that's in the 2nd normal form is in the 1st normal form. So, if something isn't in the 1st normal form, it isn't in any normal form, and you should probably attend to that. So it's more difficult to be in the 3rd normal form than it is the 2nd normal form, and more difficult to be in the 2nd normal form than the 1st normal form. So we're going to look at an example here. We've got a database discussing services performed for a local garage. You might have been hired by this garage to put a database system together because they certainly need to keep track of what services were performed for a variety of reasons. So we're going to focus there, and you might see you might walk into the job on the first day and find that their existing database looks something like this, what we're calling the raw data. We've got a VIN number, services performed, comma separated list, and then a customer name, and then a model. Now, the first normal form, like I said, the easiest one, is that every table row contains only one value. Every field in every column, in every row. So if we look over here at the 2nd row in the raw data, we say that Patricia had 2 services performed on her Equinox. Well, in this services performed column, there are now 2 values, oil change and alignment, and they're really separate things. So what we should do is rearrange this table so that there's oil change on one line and alignment on another line. That is going to mean that there's some redundancy, because we're going to have 2 rows. They're going to have the same VIN, the same customer name, the same Equinox. We'll find out later on ways to reduce that redundancy. But consider the case. You're asked to count how many oil changes a dealer has done. It's important to know how important oil changes are to their revenue. Somebody asked you, so you took a look at this database. If it's in this raw data form, then you could say, oh, is the services performed field equal to oil change? If so, pass the filter, and then you count the number of rows outputted. That wouldn't match this second row, excuse me, because oil change is one of the things listed, but it isn't the entirety. By having multiple fields in a single cell of the table, you increase the complexity and the potential for mistakes in any data analysis. Because you can't just say how many are oil change, you have to say how many contain oil change, and what if they contain oil change twice? You should probably count that as 2 oil changes. I don't know why you would do 2 oil changes right after the other. That might be a reason. I'm not a mechanic. Do you have to code that as a separate case? About 3. There's just a lot to consider, even on a very simple analysis like count oil changes. At the end of this course, you'll be able to perform much more complex analysis, which would make this original data format much more difficult to implement. Okay. So once you've gotten one value in every cell, you're in the first normal form. Congratulations. So we've rewritten the table. It's a little longer now, but it's in the first normal form. Analyzing data from this table is going to be much easier. Once we got into the second normal form, it's possible to get in the second normal form. The first step of being in the second normal form is you have to be in the first normal form. But the second normal form adds an additional requirement. You must have a primary key. As we've discussed, a primary key is a column. It's usually the first column. It could be a combination of columns, but typically it's just one column that uniquely identifies what row. So in this case, we've got a little bit of a problem. This 1FA FP33Z to Patricia's escape. I'm not worrying about the fact that her car changed all of a sudden. But Patricia's car shows up in multiple different rows. If we wanted to say delete a row, how would we tell SQL which row to delete or modify? It's not clear that we could do that in any sensible fashion. It makes it very difficult because there's no primary key. So the easy way to take something from the first normal form to the second normal form is you just add a column. It's usually called ID, and it just counts the row. So the first one will be 1, the second will be 2, the third is 3, and so on. And then we can refer to the row with ID 4, and that would be this one right here. You could also start from 0. It doesn't matter as long as we mentioned before, the primary key is unique for among all the rows of that table. So if we had a table of cars, VIN would be a perfectly reasonable primary key. We have a table of services, and multiple services could apply to the same VIN number. So VIN is not a good primary key. We'll have to add a column over here. So we've got we added a column ID, and it just goes 1, 2, 3. You could make it 0, 1, 2, 3, 4. It doesn't really matter. In fact, there's something called a UUID, which is just a random number that's so big it's essentially mathematically impossible for it to be duplicated. And that would be a reasonable primary key as well. Although documenting such a primary key might be difficult. I don't suggest UUIDs for primary keys in professional tables. It's usually easy enough to count. Often, your database system will allow you to automatically generate a primary key, just like this. So here we have services, this vehicle, this oil change. Now, here, this table, though, we've simplified things a little bit. And to get to why, let's take a look at the third normal form, which is significant, is a bit more complicated. I did want to ask, are there any questions about either the first or second normal forms? Okay. So here's a summary of second normal forms. We've got a unique identifier for every row, probably a single column. In some cases, you're going to have two different columns. And all, as an example, when you might want more than one column, I worked for insurance companies. A policyholder can have multiple claims on something like health insurance. So if we had a table of claims, I've worked with tables of claims, you usually have the policy ID and then the claim number. Is this the first claim, the second claim, the third claim? And those two together identify which row in the claim table we're talking about. So that would be two columns, but that's the exception rather than the rule. Normally, one column is all you need for a primary key. And then everything in the column should depend only on the primary key. That's how we make sure that every row has a unique primary key. And often when converting to these normal forms, you're going to want to create new tables. A lot of creating the new tables is to reduce the idea of transitive dependency. That's a mouthful. Let me break it down to you. Dependency, that's pretty straightforward. When you were a kid, your parents on their tax forms wrote you down as a dependent. You needed their support to survive when you were 6, and they got a tax kickback from it. This isn't a tax class, but I'm sure you've seen that form, that line on the tax form. You may have dependents of your own. Dependency means something depends on something else. In terms of data, something is determined by something else. For instance, if you know the VIN number of a car, you can go online and look up exactly what model year it is, what make is, what the model is, often what the trim is. I think you can look up the trim as well. You in some cases can look up the owner, but that's a little more complicated. So we would say that the make of a car depends on its VIN number, because if you know the VIN number, you can figure out what the make is. If you do enough research, if you do enough work. There's only going to be one make for any particular VIN number. Note that the other way around is not true. If you know, for instance, that I drive a Volvo, there's no way you can tell what my VIN number is just based on that. But if I told you my VIN number is, you could look up and find that I drive a Volvo. Transitive is... So, transitive comes from mathematics. If I know that x is equal to y and y is equal to z, then really x has to equal z as well. That's called transitive. So if A tells you what B is, if B depends on A, and B tells you what C is, so C depends on B, then A can tell you what C is. It's pretty easy. If you know what A is, you look up what B is, and then you use the value of B that you found to figure out what C is. For instance, if I looked up had a VIN number for a car, I could figure out what the model was. Now, the only people who make Prius is, I want to say Toyota. Let's pretend it's Toyota. I don't know cars. So I could figure out what the make is that way. I could figure out that VIN number points to Toyota because I knew it was a Prius. That's transitive dependence. The same pattern, A gives you B, B gives you C, so A gives you C, is transitive, and dependence is because you can use one value to find another value. Transitive dependence happens all the time. It is a data pattern that you're going to use extensively, really, though we're not going to use the term that much. Transitive dependence, we want to avoid it to get to the third normal form. And that's really where breaking things up into more tables comes in really handy. So let's take a look. Here they have an example. If you know the city, you can find the zip code. And if you know the person, you can look up their primary residence and find the zip code. So that would be transitive dependence. Here, in the case we're talking about for the garage, if you know the VIN, you can find the customer. And if you know the customer, you can find the model, and the model will tell you the make. That's transitive dependence. Not only A, B, C, but there's also transitive dependence all the way down to D, make. And we want to avoid that. So what we're going to do is take this table, and instead of writing down the customer, my apologies, we're just going to write down a customer ID. And so instead of the customer's name, we have a customer ID now. Instead of writing down that it has a Prius, which is a Toyota, we can just write down it's a Prius and then look up in another table that every Prius is a Toyota. So Prius is a Toyota, and then this table, I mean, we've created more tables. It sounds like we're just making more work for ourselves. But these smaller tables, called lookup tables in data science, they're really small. I mean, how many makes of car are there? Maybe a couple dozen? And for practical purposes, there's like 8 that you've got 95% of all the cars, at least in the United States. And there's, maybe 100 models. So this table's, you could literally write it down on a piece of paper. That is a tiny table by data science standards. Model, it's a couple pages. It's, again, very small, very simple. Not that much data to enter in. Then, when we list a vehicle, we can say this VIN number goes to this customer and this model. Boom, we're done. This table is now much simpler, and we've avoided transitive dependence. Okay, any questions about that? Great. Let's go on to an activity where we'll discuss the principles of the 3 normal forms.